record. I am screen recording. All right. So we're looking at plotting an equation on a graph. And so far, what we've learned are two methods. The first way is manually, you could say, just point by point. You pick a bunch of x values, right? And you put in the corresponding y values. When we do that, it works well enough, but doesn't necessarily save us any time, and we may miss some important information. The second way that we looked at before Christmas was using certain information that we can get out of the equation. We can find the x-intercepts and the axis of symmetry. I don't know if you remember what that is. If you don't, look it up. Axis of symmetry for a quadratic equation. It came from x equals minus b over 2a. All right. Look that up in your notes. But what we're going to look at is the third, and in some ways it's the easiest way. The easiest way, we just use a graphing calculator. Use a graphing calculator. So we can do this one today for a little bit to break up algebra, and then tomorrow we'll talk a little bit more about the algebra version. Okay, so how do we use a graphing calculator to plot this? You just put it in. So if you have your graphing calculator, right, let me show you what to do. Bum, bum, ba-dum. Okay, here is my beautiful TI-84 plus. Okay, and we're going to be plotting this equation. So you go to y equals, and it was x squared, right, plus 2x plus 5. Is that correct? Is that what we're doing? Okay, if you don't have your... Yes. Oh, sorry. Yeah.
What do I click to get there?
Y equals. See this button here?
Yeah, sorry, I was just getting my calculator, so I wasn't here.
Yep, sure. So y equals. Hello, Lucy. We are doing some graphing calculator work. Okay. If you don't have a graphing calculator, open up GeoGebra and try to follow along if you can. Then you press enter. All right. And you hit graph. Amazing. That's it. You're done. But we need to find out some features on this graph. Okay. How do we do that? Well, let's change our window. It's a bit too zoomed out, so I don't need all this negative stuff. So I'm going to change my y min value, and maybe let's change our y max value a bit, so we're going to shift up. So that's
Mr. Lu, how you graph it? You
hit this graph button on the right here.
Yeah, if I do that, it says me like error.
How did you? Do you have y1 equals like me here?
Yes. Wait.
X squared plus 2x plus 5. And then you hit graph. What kind of error does it say?
Invalid dimension. Wait.
Okay, so let's go to window. All right. I want you to match mine. So minus. Don't forget to press the minus button down here. Let's make this minus 1. And let's make this, I don't know, 15 or something. And let's change this to minus 5 and 5. Okay. Did that help? Change your window settings, guys, to match mine exactly. Okay, so x min, x max, y min, y max. Okay, you should have a parabola. Okay, you should have a parabola. I want you to notice something. What do you notice about this parabola? Just visually, what do you see? How would you describe this to someone? Anyone?
Parabola.
Okay, what? Yeah, it's a parabola. What else would you? How else would you describe it? Okay. Look, guys, it's kind of like floating up in space, isn't it? It's not touching the x-axis at all. All right? That's very important because what were we talking about yesterday? The fact that this doesn't have any solutions. Okay? Just because it doesn't have any solutions doesn't mean we can't graph it. Why? Because what we're doing is graphing y equals x squared plus 2x plus 5. So this is basically this is basically the graph, right? We're asking, is there anywhere on this graph, on this equation, where x could make the function 0? It could make the whole equation 0. All right, we learned yesterday the method to find the discriminant, right? The discriminant was b squared minus 4ac. And we said, oh, it's negative, so there are no solutions for this equation. If it cannot equal 0. In other words, if my quadratic equation has no solutions, it does not touch the x-axis. See this? It will never have an x-intercept. All right? This is very important. I'm going to write that out as a note in a second. But before we do that, let's go back to the graph on the calculator, because we can find out some information from it. And in a parabola, we're always interested in the, what's this point called down here, where it goes zoop? What's that called? This bottom bit. It's a.
Oh, I forgot.
Starts with M. It starts with M. The min.
Wait, is it the meniscus?
Minimum. It's the minimum. All right. So we can find the minimum on this graph. How do we do that? We go to the calc menu, calculate. So second, right? Calc. We're going to look for the minimum of this graph, right? So here's minimum, enter. And we go to the left somewhere here, the left bound, the right bound, and somewhere in the middle. Okay. So the minimum occurs, okay, that's a typo. Just go to -1 and 4. So that means, guys, if I draw this over here, this is the minimum, and it occurs at -1 divided by 4. Sorry, -1, 4. I don't know why I said divided by. That's the minimum. All right. So the two important points to come out of this parabola, the minimum is here, and okay, there are no x-intercepts. That's a weird thing to think about. We haven't really talked about it yet. That's why we're doing it today. Okay, there are no x-intercepts. What's an x-intercept again?
When it touches the x-axis?
Yes. Okay, good. So x-intercept does not exist. All right. So in a nutshell, okay, in a nutshell, okay, if the quadratic equation has no solutions, the graph will have no x-intercepts. Okay, it's kind of floating above in positive space. Does that make sense? You know how I like to draw red boxes sometimes in class around important points? This is one of those points. All right. If the quadratic equation has no solutions from what we did yesterday, okay, using the technique we learned yesterday rather, the graph will have no x-intercepts. Let me try and format this a bit better. All right, I can't, but you can read that. All right. So what could happen is, you know, yesterday I had that mix of quadratic equations. You may be asked to plot this quadratic equation, right? If it's a calculator paper, you just do the technique I did. You just put it in the calculator and you find out what the important points are. Okay, we'll do some examples tomorrow. And then this is just a clue. If it doesn't have any solutions, you can still plot it, okay? But it just will be floating above the x-axis, all right? You can write that, I guess. It's kind of floating in positive space. Okay, floating. Does that make sense? Any questions?
Yes, it still doesn't work on my calculator. Like, I can't graph it, so.
Oh no. Maybe, all right, I'm just gonna stop recording for now.